Oh yeah, it's part 3 of 10.3 extension. Choosing appropriate measures. How can we use a histogram to determine the appropriate measures of center and variation? All right, sweet. So remember, if we have skewed data, we're going to use the median for the measure of center and the IQR for the measure of variation. And if we have symmetric data, we're going to use the mean for the measure of center and the mean absolute deviation for the measure of variation. And of course, any data display that shows us that shape of the distribution, remember, dot plot will, a histogram will tell us which measures of center and variation to use. Of course, a stem and leaf plot, a little more difficult, but you can still see that distribution. But histograms and dot plots are the best. Okay, bordering states. So, I should read the question first. The frequency table shows the number of states that border each state in the United States. So like California, for instance, borders Nevada and Oregon, Arizona. So display the data in a histogram, the number of bordering states. Okay, remember we have on a histogram, we have intervals, right? They're all the same size, right? And they're all adjacent to each other. And it's basically a number line, least to greatest. Frequency is how many of the data are in that interval. So bordering states, 0 to 1. Frequency is 3. So what I'm going to do, well, the first part A, I should actually read it again. Display the data in a histogram. 3 is about here. I apologize for my very bad, not great drawing, but that's okay. Bordering states, 2 to 3 states that they're bordering. 13, okay, so that's about here, maybe? Like I said, this will not be perfect, but I think it should tell us enough about the shape of the distribution to figure this out. 4 to 5, there's 22. Whoa, a lot of those. And of course, as history has gone on in the United States, the states have gotten bigger and bigger and bigger as they moved out west. Okay, 6 to 7 states, 10. Okay, whoa, that's a big bar, whoops. And 8 to 9 is 2, just a measly little tiny 2. All right, not great. Okay, so what do these data look like to you? Is this skewed left, skewed right? Is it symmetric? Well, to tell if it's symmetric, I always just think of if there was a line of symmetry down the middle. Is the left side roughly a reflection of the right side? I'd say roughly. I'd say it's closer to symmetric than skewed left or skewed right. So if the data are symmetric, and we're asked, what are the most appropriate measures to describe the center and the variation? If they're roughly symmetric, then the measure of center is going to be what? The mean. Because symmetric data, the mean's the best. And the mean's gonna be somewhere in here. It's the balancing point of the data. So it's gonna be a pretty good measure. And then which measure of variation is based on the mean? Well, it's not the range, it's not the interquartile range, it's the MAD. And in the MAD, mean absolute deviation, it has the word mean, right? So our data are symmetric, measure of center is the mean, measure of variation is the MAD. Okay, that concludes 10.3, choosing appropriate measures. I will catch y'all for the next lesson.